All right. Good morning or good afternoon, depending on when you're watching a video. For me right now, it's still morning. It's like 5 something. All right. I'm going to apologize for the audio. My microphone, the USB thing went out on it, so I'm using the one on the computer. So you hear a little background sound from time to time when the fan turns on. Sorry, can't do nothing about it. All right. We're going to go over reaction types today. So you have your notebook out. You can put this in your notebook. Label of the next blank page: chemical reaction types. All right. So previous 2 days we're going over balancing chemical equations. I think we've got pretty much that mastered down. Now we're going to just add a little twist and talk about reaction types, and we will be balancing those two later on. For right now, just worry about the reaction types. So there's 4 types of reaction types we're going to care about. And I forgot my cheat sheet, so hold on one moment. Actually, I forgot to print it out, so oh well. There's 4 different types. In the left-hand column, this little column you have in your notebook, you need to put synthesis. Then we're going to cover decomposition, single and double replacement. Right now, we're just going to do synthesis. Okay, and you put the letters A plus B reacts and creates A, B. So I also got the snifflies too. I'm a little sick. All right, let's do the equation that we've always used a lot in class. H2 plus O2 reacts and creates 2H2O. And actually, I'm going to get rid of that 2 for the moment. Okay. So in a synthesis reaction, it means if we have 2 different sets and they come together to form one, we call that synthesis. So I have this, I'm going to put this as A here. And I have this, let me change my colors, B here. They come together and make an AB where they're bonded together. All right, that's all it really is. You have these 2 separate. They're going to hold hands and become AB. All right, and actually I should have probably put those on top. But if you didn't, that's no big deal. If yours is on bottom, that's fine. Okay, now remember the previous 2 days we can go over balancing. Is this chemical equation balanced? Let's say I have 2 H's over here, 2 over here, yep. 2 oxygens, 1 oxygen, so it's not, so we need to balance it. So let's go and balance that really quick. I'm going to switch colors. Okay. Go ahead, H into O, H into O. All right, I have 2 H's and 2 oxygens. On the right hand side, I have 2 H's and 1 oxygen. I need to make this side equal to this side. Well, if I have this 1 here, this 2 over here, I could probably add a 2 here to make that side even. You want to put a 2, which means this is now 4, and this is now 2. The left-hand side, make sure that's also even. Well, it's not. Hydrogens here are not the same. So I can add a coefficient up here. Wrong thing. Coefficient of 2, which will now make this into a 4. Now these sides match, and these sides match. Cool. So a synthesis reaction is where you have A plus a B, going to come together and make an AB. Easy peasy, lemon squeezy. Okay. Let's go scroll on down. I'm actually going to put a line here for me. I know this is separating it. Awesome. The next one's going to be called a decomposition. When we think of the word decomposition, we usually think about breaking apart, decomposing, breaking things down. Well, that's exactly what this is. Okay. I'm going to just use different letters for this, just so the top one you don't get confused with A, B, and A plus B kind of thing. So I'm going to use X and Y. I could use A, B, but I just don't want to confuse anybody. Oh, I messed up. X and Y. They're together, and they're going to break apart. So X and Y are together. As they react, they're going to break apart. I actually should probably put these like that. I don't know why I wrote it that way. It's 5 in the morning, that's why. Okay. So an example of this would be, let's take the same one we had previously. We have the, let's actually just put H2O2. And they're going to react. And they're going to separate to be H2 plus O2. They were together, now they broke apart. That's decomposition. They're decomposing. Bring it into smaller pieces. That's it. All right, now let's balance this chemical equation and make sure we get all that balanced. So I'm going to put a little squiggly there. Put down my elements, list them down. H and O. I have H and O. Copy it down the same way here to over here. Remember, do not change the order, or you may have a bad time. All right. And I realized I did make it boo on here, but it's good for the notes. It's okay. So let's see, we have 2 hydrogens, 2 oxygens, 2 hydrogens, 2 oxygens, and it's good. Yeah, I meant to do something else on here, but oops, it's okay. For the purpose, y'all got it. I meant to put a 2 right here to throw a twist on there, but not bad. But y'all get the ordeal. All right. Let's take a moment there to get everybody to write it down. And we're going to do the next one. I'm going to go to the next page for me. Let's go to, there we go. Let's do a single. Oh, let me change the color there. A single replacement. Now I forgot how to spell replace. I'm trying to put an R there. There we go. A single replacement reaction. This is where it's going to get a little bit more complex, but not too much. Let's say I have an A. Let me just switch this color to a green. A B. Let's make a blue, a C. Okay. So we have A plus a BC, which are together, are going to react. And this is where it's going to get weird. Where A and C are now together. And B's by itself. So these two are together. This one's going to come in and take one of their spots. All right. So basically, the one switch swapped. Let's say you're at a dance, and there's just, just friends. No one's dating. Everybody's just friends. And there's 2 people dancing, and one person comes and walks in like, "Hey, that's cool. You're gonna go get some food, and I'm gonna take your spot, and we're gonna continue dancing." So like these 2 are dancing. This one's come over here, and he's gonna join the dance while B goes get some food. one replaces the other. Okay? Let me write down the equation for this. Let's pick aluminum, Al, plus Cu. We'll say there's 3 of those just for the fun of it. And NO3, 2. I don't like that little bracket there. It's going to react and create a 2Al, NO3, 2. I'm running out of space. Make sure you move mine over a little bit. We shouldn't usually do that, but whatever. Plus 3 Cu. All right. So this is my A. My Cu, which will be my, get back to green, B. And my NO3 will be my C. Notice it doesn't have to be just one element, it could be a compound. Things that are bonded together. All right, let's see how they moved. On the right hand side, we have A. My copper is my B. And my NO3, 2 is my C. Just notice how they just switched, that's all. The plus and plus. So here, A took B spot. All right. Go ahead and put a little line on here. Now I want you to practice trying to balance this one. I put the elements down for you. Al, Cu, nitrogen, and oxygen. Copy it down the same way over here. Ooh, wrong pin. Al, Cu, and O. There we go. And try to balance this out. Give you a few minutes. I do that. Check my email. All right. So if you have this balanced, you should have a 2 right here, a 3, a 2, and a 3. The only thing that should change would be a 2 right here. Okay. I'm gonna leave this part blank to make sure everybody actually does it. Because when I'm looking in the notes and I see that part blank, I know you just skipped the video. All right, let's do another one. I'm going to switch another page just because I'm writing really big. All right, and the last one is going to be a double replacement. This sounds like it'll be harder. It actually is a lot easier than the single one. Okay, now we have the letters A, and C. Remember, the letters really doesn't matter. We're just trying to show they're different. Plus, I don't know, D, and the purple, E. They're going to react, and this time, this one and this one, they're going to switch partners. So A is going to be with E now, and C will be with D. They're just going to switch. So I have now A and E are together, and C and D are now together. They just switched. So A's here, and C goes over here. For D, that one's together. They basically just switching around. That's all. Okay. Let's add an equation for this one. This is going to be quite a large equation. Right, we have, why am I doing that in green? I have no idea. So I have Pb, which is lead, NO3, 2. Ooh. I have an issue with mine here. I wrote down me a little practice one here, and I realized I had a bad reaction with that. Uh-oh. Let me come up with another one real quick at the top of my head. I was trying to make one, but realized it's not gonna work. Which happens all the time. Let's see. What element could I use? So when I made a practice one, I thought I was doing one in my head right, but it just was not working. Okay. Let's see. If I use a GPR2. Okay. Let's try another one. Sorry. Let's do AgNO3. Get those combined. Be ionic, but okay. Ooh, good, ionic. That's actually a key part here. Plus NaCl. These are going to react. Okay. So going to react to create AgCl plus NaNO3. Okay, so I'm going to label this. I'm going to move mine down just a little bit. Now my Ag is going to be A. That's A, and here's my A. My NO3, that would be my C. Sometimes this could be a little difficult just trying to figure out what would be a letter kind of thing, but it just takes practice. Now I know N is not itself, but it's not just its own letter. But since it moves as a chunk over here, I know it's this whole piece. Okay. So my C. You see I got a D here. My Na, let's make that green. A D. D. My chlorine will be my E. Now you could use A, B, C, D if you wanted to. I just did this up previous in the notes. It doesn't get mixed up. That's all. The chlorine is my E and my E. So notice we had AC first. And at the end, A and C split up and they're separate. That's all. And DE, they were together. Now they're separate. They switch spots. That's all it really is. Let's see. I'm balancing this. It's actually already balanced. Just to make sure, I'll do it real quick. But yeah, it's already balanced. So we have Ag, N, O, Na, and Cl. That is a lot. All right, we have 1 Ag. Nitrogen is 1. Oxygen is 3. Na is 1. Chlorine is 1. On the right, 1 Ag, 1 chlorine, 1 Na, 1 nitrogen, 3 oxygens. It's already balanced. Sorry, when I came up with it, I should have picked a different one. Or made it where it wasn't balanced, but y'all get the dealio. Alright. Now I'm going to give it some practice ones here. So you could write these in the notebook. Now on here, there's actual different things that on here that we haven't covered yet, like this S and G's. This S means solid. Oh, you can't see that. Let me move my head out of the way. There we go. This S is solid. Solid. G's for gas. AQ's for aqueous or liquid. AQ's aqueous or liquid, like agua. S is solid. liquid, gas, gas, gas. Just don't worry about those right now. This one, you're not going to balance it. I just want you to determine if it's single, double, sorry, not double, single replacement, double replacement, synthesis, and decomposition. And actually, before we do this, I forgot to make one comment. If we go back to the previous page for double, this is a key part. This word is going to be ionic. Notice the bonds, like Na and Cl, they're ionic. Double replacements will be having ionic bonds. Other ones could too, but double replacement will always have ionic. Okay, so I just want to throw that out there. Let's do the first one. We have, I want you to label it like this when you write it down. A and A. All right, Cl, and sorry, that's a typo. That should be a Cl, not a Ci. Is a B, and that's a B. And oxygen would be the C. Sorry, I had a brain fart. Okay. All right, so this would be a single, double, synthesis, or decomp. Well, since it broke apart, this would be a decomposition. Okay, let's go to the next one. And again, my face is in the way. Sorry about that. Again, label it again. Ag will be my A. Right hand side, we have an A. My NO3, usually NO3 is going to be bunched together. This is a polyatomic thingy. All right, so we got a B and a B. All right, we have K, potassium. That's going to be a C and a C. Last one's chlorine, and that's going to be, just pick another color here, D and a D. So A, B were together, now they're split apart. C and D were together, they split apart. It happened twice. So this would be a double replacement. Okay. Let's do one more and the rest is on your own practice. All right, we have hydrogen and oxygen combining to make H2O. So hydrogen will be my A, oxygen will be a B, and come together and make AB. So two separate things coming together. This will be a synthesis. All right. So write the rest of them in your notebook. Finish them out. Once you get done with this, you'll have some practice in Canvas. There's so much practice in Canvas for you. All right. Well, hope you have a great day. Adios.